Good morning, colleagues. Franca, over to you.
Good morning. Good afternoon, everybody. Welcome to today's session of ITU Digital Transformation Dialogues. I'm Franca Vinci, Head of Learning Services at the United Nations International Computing Center, and I have the pleasure and honor to be the Master of Ceremony for today's session. This is only one of a larger series called Digital Transformation Dialogues and led by the International Telecommunication Union. This series has the scope of bringing together experts from different industries and specialties in different formats: webinars, Ask the Expert sessions, fireside chats like the one we are having today. The session today will delve deep into how quantum computing can support us to find revolutionary solutions to the biggest challenges humanity is facing. We will try to explore its potential in climate change, healthcare, and more. We will also try to discover how these innovations can help us achieve the SDGs and drive global progress. Just a quick information before we start. If you have any question you would like to raise, please do so by typing them in the Q&A window that you can find at the bottom of the screen. All questions from the audience will be taken during the Q&A session at the end of the fireside chat. We would kindly ask also to specify the city and the country you are connecting from next to your question. Finally, I would like to make you all aware that the session is being recorded and the recording will be made available on the event website. Now, it is my pleasure to introduce our moderator, Dr. Bilal Jamoussi, Deputy Director of ITU Telecommunication Standardization Bureau. Dr. Bilal Jamoussi will introduce today's topic and our distinguished speaker. Dr. Jamoussi, the floor is yours.
Thank you very much, Franca. Good afternoon, everyone, and welcome to our distinguished speaker today, Georges-Olivier Pascal, and all the colleagues who are joining us online. As you know, quantum information technologies is an area of focus and interest for the ITU and its members. We've had a focus group that worked on this topic for a few years and produced a number of reports and webinars and standards. We have some standards in the area of quantum key distribution and quantum security, but quantum information technology also includes quantum metrology and quantum computing. So today's session is focused on quantum computing, where we would like to explore the transformative potential of quantum computing, its capacity to address some of humanity's most pressing challenges. Quantum computing is not just about achieving unprecedented computational power. It promises to revolutionize fields such as climate modeling, healthcare, energy optimization, and many more, by solving complex problems with unparalleled speed and precision. So as we look towards a future shaped by these groundbreaking technologies, the importance of establishing robust international standards cannot be overstated. Standards set by the ITU and other organizations provide the necessary framework to ensure capability, security, ethical use, fostering a global ecosystem where quantum computing can thrive. So to help us navigate this exciting terrain, it is really my great pleasure to introduce our distinguished guest, Georges-Olivier Raymond, CEO of Pascal. Georges-Olivier is a leading figure in the field of quantum computing with a master's and PhD in quantum physics. He has a track record of pioneering achievements, from demonstrating the control of single atoms with optical tweezers to advancing technologies in biotechnology, defense, semiconductor, and others. So, and under his leadership, Pascal has become a trailblazer in the quantum computing landscape. So thank you, Georges-Olivier, for joining us today. And let's dive into our questions. The first question we'd like to explore is some of the recent advancements. To start, we want to look at what are some of the most exciting recent advancements in quantum computing that you have witnessed, and how are these developments shaping the field?
Well, first of all, I would like to say hello to everybody and to thank the organization for this great event and for inviting me today, and also thank you, Bilal, for the kind introduction. So actually, indeed, we are living a very exciting time. Actually, in quantum, breakthroughs are happening much sooner than expected. What I can tell you from my position of CEO of Pascal is that quantum computing already delivers real business value. We already have a first product. We have co-developed use cases with companies addressing real challenges they face. I can mention optimizing satellite trajectories for Thales Group, or improving material formatting for BMW. And these growing case studies developed between companies and quantum players just confirm the market trends. And according to BCG, these achievements, point to enterprise-grade quantum computing generating business by 2025, business value. And same prediction with Gartner, actually. By 2027, they forecast that 25% of large enterprises will deliver an evolutionary advantage over non-quantum enabled technologies through quantum initiatives. And today, there is a growing awareness of the need to consider the impact that quantum computing may have on various markets. And even though it will take a few more years for the technology to reach full maturity, there are already near-term benefits or low-hanging fruits from investing in quantum computing. That being said, despite its promise, there is a notable gap today in private investment in the sector, particularly in Europe, where the private investment ecosystem lags behind other global leaders, such as the US or China. And this investment shortfall could pose a risk of stunned growth and innovation in the region. To address this, Europe needs to foster stronger capital market union, the CMU, to bridge this investment gap. The timing is right. With increasing concerns over the environmental impact of AI adoption, there is a pressing need to accelerate the development of quantum, or quantum for AI. It's a significant opportunity to address this dual challenge of enhancing computational performance while minimizing environmental impact. The reason is that quantum computers are very low energy intensive, and their application can also help us solving the most pressing issues we are currently facing.
Great. Well, 2025 is the year of quantum, as you know. What do you believe are the key milestones the industry needs to achieve over the next few years to ensure that quantum innovation have a tangible impact?
Well, that's a very good question. So the first challenge, the first milestone, is to move from, let's say, from the lab, from R&D into production, to deploy a resilient, sustainable quantum industry supply chain. And through initiatives like the CHIPS Act's pilot line, Pascal is helping to build this foundation. The second point is the right adoption by end users. We have the first product, the first applications, the tool to program a quantum computer with an abstraction of the quantum complexity. So basically, the technology is available to the mass. And we need this wide adoption by end users, because we need to be sure that we are developing the right product that is needed. We need to be sure that we are addressing the bottleneck that our end users are currently facing. And this is only by integrating quantum solutions at scale across industry and public sectors that we can drive this demand that sustains innovation. And again, it's a virtuous cycle. You know, only if end users dare to adopt quantum solutions at scale can quantum industrial players continue to innovate, delivering technologies that not only meet end users' evolving needs, but ultimately address these broader societal challenges that we are facing.
Great. Georges-Olivier, I think in your introduction, you touched on examples in the space industry, in the automotive industry. So quantum computing has the potential to revolutionize various industries. Could you share some other examples of how this technology could transform sectors like healthcare, finance, energy, etc.?
Yeah, absolutely. And I will mention that. And just to let you know that we have, real-world implementation on real hardware in all of these verticals. So maybe the first vertical I would like to address is simulation and maybe quantum simulation. The speed of quantum computing is extremely useful for solving complex analytical problems like simulations. And quantum computing operates according to the same law of nature as molecules and materials, namely quantum mechanics. And this allows us to model complex molecular interactions that classical systems cannot handle, opening up a new world of simulation possibilities. We are, as an example, working with EDF, the French electricity utility, to better understand the aging and the corrosion of materials inside the nuclear plants. And this is a dire problem for EDF. Regarding drug discovery, we can also improve the drug discovery. As an example, we worked with another French company, Qubit Pharmaceutical. And this is of tremendous importance because if you are able to reduce the development time of new drugs, you can also bring a lot of value. And and the next sector I would like to mention is optimization, basically logistics, all very complex problems where you have a lot of parameters and you try to find, like the needle in the haystack, if you want to, and that's a challenging task for classical computer that a quantum computer can solve. I mentioned Thales in the optimization of satellite trajectory, but I could also mention CMA CGM, a company doing overseas ship delivery, and this is again a hard task, managing the fleet of ships, managing the fleet of containers, because each ship has tens of thousands of containers that they need to drop at different harbors, and finding the optimal route, the optimal solution to minimize the delivery time, the fuel consumption, and whatsoever can be addressed by a quantum computer.
Great. So optimization, simulation, tasks that are very compute intensive. You have some concrete application of quantum computing there. Now let's look at the challenges and hurdles. You mentioned a bit in terms of finance, but every new technology comes with its challenges. So in your view, what are some of the biggest hurdles currently facing the development of widespread adoption of quantum computing?
Well, the first one is the scarcity, and it's kind of a double scarcity. First one being the hardware. And today, quantum computers there are very few of them. Pascal is among the only few companies being able to manufacturing them at scale. We as an example, we already have one deployed in a data center in France. The second one being deployed, in the coming days in Germany, and we also have our internal resources. But still, if you want to, there is a real scarcity. The second one is also the scarcity of talents, and especially because there is also a competition with AI on this. And what we witness today is that there are some kind of local hub where you can find a lot of talents, of skills, but some other are, let's say, are not as well deserved, creating kind of a geographic imbalance. But the good news regarding the talent is that, we, thanks to all the work we did at Pascal to abstract the quantum complexity, I mean, classical data scientists and mathematicians, they can use our technologies. We know how to train them in university. We just need more of them. So that was the first aspect. And we also see a fragmented and competing normative frameworks around the globe, which is also a challenge. This can pose significant challenges for companies seeking to expand and deliver their quantum solutions. And a concrete example of this issue is the multiplication of new export control restrictions in national laws such as in the US, the UK, Japan, Canada, Spain, and just to name a few. And the more barriers to global international trades are, the less companies like Pascal can expand globally via effectively exporting its QPUs, quantum processing unit, on the international scene.
Right. So some of the challenges are in terms of capacity, in terms of people, scarcity of hardware, but there is also an enabling regulatory environment to allow for freer movement of quantum computing hardware. Maybe this is where some of the international standards could play a role. So as this field of quantum computing continues to evolve, what do you see as the key areas of international standards that could support or accelerate the achievement and the advancement of quantum computing?
Well, first of all, I think it's crucial to ensure both international industrial participation to develop commonly agreed standards at a global level, avoiding the dominance by a few large players via their national standardization agencies. It is only, I mean, according to me, via global industrial collaboration that new standards will reflect global market reality, avoid market locking, and foster an equitable access to quantum technologies provided by all providers to the economy. And this is why Pascal is already deeply involved at international, European, and national level to be the standard setter in quantum computing. Pascal is the chair of the European Working Group on Quantum Computing and Simulation of the European Joint Technical Committee, the GTC 22, representing 34 European countries. And Pascal is also a key member of the International Technical Committee, the GTC 3, shaping international standards in quantum computing. And by being part of this strategic group of the GTC 3, Pascal also works towards guaranteeing that international standards capitalize on the standardization activities developed at the European level. The coordination in the development of quantum standards between the European and internationally, is an absolute necessity to avoid a jungle of standards where individual company might act unilaterally. This behavior can restrict international trade and industrial expansion for startups. Please remember that we are still a small company, so it's hard, to be active in this domain. And so, particularly if large companies establish their norms, their standards via, let's say, a single standardization agency unilaterally. Standard setting in quantum computing is an absolute business strategic priority. As explained, Pascal is leading the development of quantum standards internationally and at European level in two key areas: standard development to support the hybridization between high-performance computing, HPC, classical computers, and quantum computers, which would accelerate technology integration and enable more robust solutions based on interoperability. And finally, standards development to guarantee that quantum hardware and software algorithms are developed in a way that maximize their performance to enable high value across various industrial use cases.
Great. So my final question, looking to the future, and I think you mentioned a bit the connection between quantum computing and artificial intelligence, because AI needs a lot of compute power. And now we talk a lot about green data centers and green computing. So that's one area of intersection that is a positive one, I think. What other areas of in terms of the broader technological landscape do you see quantum computing evolving into? And what changes or advancements should we be prepared for in the coming years?
Yeah, well, before answering, I really want to emphasize the importance of the energy consumption, because, you know, by adding quantum computers to the current arsenal of CPUs and GPUs, we are extending their capabilities, addressing problems that they cannot solve today and that they will never be able to solve. So this will be hybrid. And we are adding a component which is super low energy intensive. So, you know, we are not participating to the acceleration of the electrical consumption, which I think is a key element. So, because we need AI, we need CPUs and GPUs, but we make them more powerful using not increasing the electricity bill. That being said, in several industries, quantum computing will emerge as key technologies in cutting-edge digital architectures. Companies will leverage quantum capabilities to tackle previously unsolvable problems while integrating hybrid models that combine quantum and classical computing, enabling enhanced outcomes and leveraging existing infrastructure. We do not need to change the existing infrastructure to integrate quantum. And I think this is a great news for the end users. Quantum technology has now reached a level of maturity where the paradigm is shifting from making quantum a reality, which is already demonstrated, to achieving quantum readiness, moving from POC into production. And indeed, as quantum hardware matures fast, industries must adapt by developing new tools and practices to harness the full potential of quantum computing, by ensuring seamless integration with technologies like HPC, AI, and cloud systems. This is key to drive value for the economy and society. And the good news is that this journey can start now because, again, we have the software, the hardware, and all the tools that are needed for the final end users to start this transformative process. So this shift to quantum readiness means that C-level executives in both the public and private sectors must proactively integrate quantum technology into core operations, even in non-digital domains, to build expertise and readiness. You know, it's developing fast. It takes time to learn and train. And in 2 or 3 years, when we will have the first ROI using quantum, I mean, people sitting and waiting will be late compared to their competitors. And what I can see today is that the gap is growing between, you know, the first pioneer trying and learning with quantum computers and the others waiting. So advancing quantum solutions means not only scaling technology, but doing so in a way that is sustainable and tailored to the needs of industries and public services. So it's a real interaction between the end users and the providers. And as quantum technology matures, policymakers become more attentive on their implications for the development of sustainable and resilient supply chains, and therefore for the competitiveness of our economies and societies.
Great. Well, thank you very much, Georges Olivier, for your insights and expertise that you shared with us today. It's clear that quantum computing has an amazing future and potential to shape our future. The thoughts and comments from today will help us all think about this emerging technology and emerging field and the potential for standards, application in other technologies, having an enabling environment, and also for investment, as you mentioned earlier. So with this, I would like to thank you very much and then hand the floor back to Franca. And thank all the audience for their attention. Back to you, Franca. Thank you.
Thank you. Thank you very much to our moderator and our distinguished speaker. Very interesting conversation. And thank you all of you for your attendance and participation in this session. As I said at the beginning, today's session is only one of a larger series. So I would like to invite you all to keep an eye on the ITU website to see information about other upcoming discussions. As you see, these events are a wonderful opportunity to delve into new developments in the digital transformation space. So please keep an eye and get ready for the next event. Thank you again for the participation and contribution to this Fireside, which is now officially closed, and hope to see you all at the next Digital Transformation Dialogues event. Enjoy the rest of the day. Thank you.
Thank you.